Today's lesson is 4.4, Writing Equations of Parallel Lines. What are parallel lines? Parallel lines are two lines that do not intersect. So if you think of railroad tracks, those railroad tracks, the left and the right side of those, they do not intersect. So two distinct non-vertical lines are parallel if they have the same slope. So what makes lines parallel is that they have the same slope. And then obviously at the bottom you see the note that says vertical lines are parallel to vertical lines and horizontal lines are parallel to horizontal lines. So how do we write equations for parallel lines? The first step is to use the given slope since lines that are parallel have the same slope. So we are going to use the given slope since parallel lines have the same slope. So if you are in slope-intercept form, you are going to identify the slope of that line and you're going to use that same slope. Sometimes you may have to convert our equation into slope-intercept form so that you can identify the slope. Once you have the slope, you're then going to plug that slope and your given point into point-slope form. And that's what we've been doing all week is point-slope form. And then your last step is to convert that equation into slope-intercept form. Again, we've been doing that all week. We distribute first, and then we move the constant over to the right side and combine like terms. All right, so here's our first example. In our first example, we are going to write an equation in slope-intercept form. So we do want it in slope-intercept form for the line that passes through the given point. So we want it to go through the given point, and it should be parallel to the graph. So we want it to go through the given point. So the given point that they gave us was 5, 1. We can see that on the graph. So they want our line to go through 5, 1. So our given ordered pair is 5, 1. And then we know that parallel lines, for it to be parallel, it has to have the same slope. So I need the same slope as the slope that is pictured in that line. And so if I look at my line, my equation is y equals x minus 8. And so I know that's really y equals 1x minus 8. And we know that the number in front of x is our slope, and so our slope is 1. So we're going to use that same slope, a slope of 1. And then we're going to take our information and we're going to substitute that into our point slope form, which is y minus y1 equals m times x minus x1. So we're going to leave our y alone, and it's y minus the y value of our ordered pair, and the y value of our ordered pair is 1, equals our slope, which we found to be 1, and then in parentheses we have x minus, and then the x value of our ordered pair, which is 5. And then we're going to put this in slope-intercept form by distributing first. So we're going to distribute that 1. So we get y minus 1 equals 1x minus 5. And then our last step is to undo that subtraction with addition so that we can get y by itself. So we have y equals 1x minus 4. And remember, when we're writing slope-intercept form, we don't need to write the 1. The 1 is understood, so we're just going to write y equals x minus 4. And I'm going to graph that to show you that that line is parallel. So y equals x minus 4, that says I have a y-intercept of negative 4 and a slope of 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. It goes through the point that was given, which it's supposed to do. And notice our lines are never going to intersect. They are parallel to each other. So they will never intersect. They are definitely parallel. So that's what we're going for. When we're writing the equation of a parallel line, we have to use the same slope. That's what makes them parallel. Example 2. In example 2, we're doing the same thing. Write an equation in slope-intercept form that passes through the given point. And so this time our given point is -8, +7. So I'm going to write down our given ordered pair, -8, +7. And then I'm also going to need the slope that would make this line parallel, because it says and is parallel to the graph. So what makes lines parallel is that they have the same slope. So if I look at my equation of our current line, I'm going to identify the slope from that equation. And we know that when an equation is written in y equals mx plus b, the coefficient of x is our slope. So I'm going to use that same slope. The slope is -1/2. And we're going to substitute our given information into the point slope form, which is y minus y1 equals m times x minus x1. And so I leave my y alone, so it's y minus, and then the y value of my ordered pair is 7, equals my slope, which is -1/2, times x minus the x value of my ordered pair, and my x value is a -8. So notice I have minus a -8 inside that parentheses, so I do need to rewrite that because we know minus a negative really means to add a positive. So it's really y minus 7 equals -1/2 times x plus 8. Then we're going to write this in slope-intercept form by distributing. So if I distribute my -1/2, we get y minus 7 equals -1/2 x, and a negative times a positive is a negative, and half of 8 is 4. And then my last step would be to undo subtracting 7 by adding 7. A -4 plus 7 is going to be a +3. So we have y equals -1/2 x plus 3. And again, if I plot my y-intercept, which is 3, which is actually in the middle because those are going by 2s, and then I count up 1, left 2, up 1, left 2, I do have a line that goes through -8, 7 that is parallel to the current line that has been graphed. And then our third example says the same thing. We're going to write this equation in slope-intercept form for the line that passes through the given point and is parallel to our equation. So instead of giving the graph, we're already going to have the point. Our point is -2, 2. And it says is parallel to y equals 4x minus 2. So what makes lines parallel is that they have the same slope. So I'm going to look for the slope of my line in that equation, and it needs to be the same. So if this is in y equals mx plus b form, my slope is 4. So I'm going to use the same slope because that's what makes it parallel. And then we substitute into our point slope form. Y minus y1 equals m times x minus x1. I leave my y alone, so we have y minus, and the y value of our ordered pair is 2, equals our slope, which is 4, and then in parentheses we have x minus the x value of our ordered pair, which is -2. So again, I have a minus a negative, and we know minus a negative really means to add a positive, so we do have to come through and rewrite that equation as y minus 2 equals 4 times x plus 2. And then we're going to put that in slope-intercept form by distributing y minus 2 equals 4x plus 8, and then we move the constant over to the other side. So I'm going to undo subtracting 2 by adding 2. So we get y equals 4x plus 10. So that line would be parallel to the given line, and it would go through the ordered pair -2 too. Example C, we are writing an equation for the line that is parallel to y equals -3x plus 10, but it also goes through the ordered pair -2, 4. So again, we're going to use our ordered pair -2, 4. And we do need a slope that makes this parallel to the current line. So what makes a line parallel is that it has the same slope. So I'm looking for the same slope. So if I look at my equation, y equals mx plus b, my slope is -3. So I'm going to use a slope of -3 because my slope should be the same if my lines are parallel. Then we're going to plug into our point slope form, y minus y1 equals m times x minus x1. I leave the y alone, so it's y minus, and then the y value of our ordered pair is 4, equals my slope, which is -3, times x minus the x value of our ordered pair, which is -2. And again, we have minus a negative, so I do need to rewrite this as plus a positive, because we know minus a negative really means to add. So we have y minus 4 equals -3 times x plus 2. And then our last step is to put this in slope-intercept form. So we're going to distribute, and we are distributing in negative. So a -3 times x is -3x, and a -3 times a positive 2 is -6. And then to get y by itself, we're going to undo subtraction with addition. We need to make sure we're checking our mental math. A -6 plus 4 is not a positive 2, but a -2. So my equation of a line that is parallel to the line given, and it goes through -2, 4, would be y equals -3x minus 2. Letter E, same thing. We have an ordered pair that has been given. So we want our line to go through 6, 4, and we want it to be parallel to y equals 1/3 x plus 1. So I have to have the same slope as the line that has been given, and if I look at my equation, my slope is 1/3. So I'm going to be using a slope of 1/3. That's what makes our line parallel. So once I have my point and my slope, I substitute those into the point slope form, which is y minus y1 equals m times x minus x1. I leave my y alone, so it's y minus, and then the y value of my ordered pair is 4, equals my slope, which is 1/3, times x minus the x value of my ordered pair, which is 6. And then this one I don't have to rewrite because I don't have any double negatives, so I'm ready to distribute. So if I distribute my 1/3, 1/3 times x would be 1/3 x, and 1/3 of -6 would be -2. We're going to undo subtraction with addition, and -2 plus 4 would be a positive 2. So we're looking at y equals 1/3 x plus 2. So this line would be parallel to the given line, and it would go through the ordered pair 6, 4. And last but not least, you have letter F. So letter F says I want to write a line that is parallel to 3x plus y equals 1, but it also goes through negative 1, 6. So I do have my ordered pair. My ordered pair is negative 1, 6. But I want it to be parallel, meaning it has to have the same slope as the given line. Now, if I look at this, this is not written in y equals mx plus b form. This says 3x plus y equals 1. So I have to get y by itself. So the way I'm going to get y by itself is I'm going to move my 3x to the other side by doing the inverse operation, which would be to subtract. So I have y equals negative 3x plus 1. So my equation is now in y equals mx plus b form. And I'm going to identify the slope, which is negative 3. And so that's the slope I want to use because parallel lines, we know, have to have the same slope. They have to be the same. So once I identify that information, then I'm going to substitute into our point slope form. Y minus y1 equals m times x minus x1. We leave our y alone, so it's y minus the y value of our ordered pair, which is 6, equals our slope, which we've now identified as negative 3, times x minus the x value of our ordered pair, and our x value happens to be negative 1. We do have a minus a negative, so we do need to rewrite that as plus a positive. So our equation now is going to say y minus 6 equals negative 3 times x plus 1. And then our last step is to always write this in slope-intercept form. So we have to distribute. So I'm going to be distributing a negative 3. So negative 3 times x would be negative 3x, and negative 3 times a positive 1 would be negative 3. And last but not least, to get y by itself, we would undo subtraction with addition, and negative 3 plus 6 would be a positive 3. And so that line would be parallel to the given line and go through the order pair negative 1, 6.